Hi everybody. I'm here with another lesson for exponential functions, and hopefully this will help you to understand even what we were going over last week better. We have for exponential functions, the biggest difference between them is it's talking about it right here. The linear and exponential linear relationships, they increase at a slow, steady pace, just like your regular line graph. While an exponential increases rapidly, it's that curved graph. So it starts off slow, and then it goes really quickly. Um, if you're looking at some of these formulas, the y equals mx plus b, if you remember, just a quick review, this is your y-intercept, and this is your slope. So when you're, that would be like, for example, if I had, let's see, my example right here, I have 300 in the bank account and I make $50 every week. That's actually this equation that it would be plugged into, where the 300 would go in right here for b, and the 50 is the slope. It would go in right here before the x. So it would be y equals 50, x plus 300. Instead of, if I didn't have a y-intercept and a slope, if I had maybe a point in the slope, then I would plug it into this kind of equation. And this one is always for those different kinds of scenarios where you have maybe two types of tickets, like an adult ticket and a youth ticket, and you're buying, this would be however many youth tickets you buy and the price of them, plus whatever the adult and whatever the youth tickets are, and the total cost on one side. So that's just a quick refresher. This is just like you can take a y-intercept and a slope and plug it into the equation, you can do the same thing with exponential functions. And I'm going to show you that right here. You have y equals ab to the x, and basically this a right here is your initial your y-intercept, and right here this would be kind of like your rate, kind of like a slope, except for your slope isn't constantly going up. What it is doing is it is being multiplied. Instead of adding the same number every time or subtracting it, you're multiplying or dividing a number the same every time. For a percent, we'll get into that in just a minute as well. So look at right here. You have y equals ab to the x. Let's give this scenario as an example. I have $1. It doubles every day. So if you're looking right here, the $1 is what I'm starting with. It's my y-intercept, and it would be right here where the a goes. That's my y-intercept, or the initial amount. And then however much I'm multiplying, if it's doubling every day, that means I'm multiplying it by 2, by 2, by 2. That goes right in here, whatever I'm multiplying. And then the exponent is unknown, and the exponent is basically represented by however much time this is happening. So if it's doubling every day, well, how many days did it double? Did it double for 5 days? Did it double for 10? Did it double for 20? And that would be what I'm plugging in for x. And you could even do a table. Let's see, I will do one for you right here. You have y equals 1, 2 to the x, and you did a table of points, you can plug in 0, 1, 2, 3, 4. And hopefully you can see that. And basically, if I plug in a 0 here, well, just a refresher with exponents, anytime you have something to the 0, it's going to make 1. Even if I had 1,000 to the 0, 1,000,000 to a 0, the exponent 0 makes it a 1. So this would just be 1, which is my y-intercept. Okay, if I plug in a 1 there, 2 to the 1 is 2, and 2 times 1 is 2. Okay, if I plug it in there, 2 to the second power is 2, 2 squared is 4, 4 times 1 is 4. 3, that would be like 2 times 2 times 2, 2 times 2 is 4, and times that is 8. And if you look right here, what's happening is it's going 1, 2, 4, 8, 16. Basically, every time, instead of me adding the same thing like we did with slope, every time I'm multiplying by 2, I'm multiplying by 2, I'm multiplying by 2. That's the pattern. Okay, whereas here I'm just adding 1 each time. Okay, but this is where you see the pattern of it being multiplied each time. Anytime you have an equation like that, the graph is going to show you your y-intercept. I'm going to move down here a little bit farther. Oops. Let's make sure you can still see the equations. Okay, so like right here, if I have the y-intercept is 1, notice it crosses right here at 1. And then if I multiply that times 2, 1 times 2 is 2. So if I plug in a 1 for x, it's going to come out with 2. Okay, if I multiply that by 2 again, that makes 4. If I multiply that by 2 again, that makes 8. And it's going to follow that same pattern. If you're looking at this next one, this formula right here is for when something's increasing by a percent. Okay, because basically if I said mostly this has to do with money or maybe big numbers like population, they do this a lot too. If you have, let's say, $5,000 and you put that in the bank, then the bank will, depending on what your account is, it'll give you a certain amount of interest. And let's say I get 5% interest. Well, 5% written as a decimal would be 0.05. If it were 10%, it would be written 0.1 or 0.10. If it's 15%, it's going to be written as 0.15. So you need to make sure you know how to do that. But basically how you would set it up is, normally if you just plug that in, because we've been plugging in, oh, it's doubling, it's multiplying by 2, so I just plug that in. But if I just plug in a 0.15 there, then what it's going to do, and you're going to see this later on when I do the next, when I do the graphs that are decreasing, it's going to be decreasing. It's not going to increase like we want it to. And the reason is because this is less than 1. This is saying I don't have 5,000, I have less than 5,000 each time. And so to avoid that, what they do is they put a 1 plus, because I have at least the 5,000. If I multiplied the 5,000 times 1 plus whatever percent is going up. So basically it would look like this. It would be 5,000 times 1 plus 0.03 what I say, 15. That would, and it would be to the x. So this would be for that. I did this again. This is what it would look like, and the graph would actually be, this would be going through 5,000. I actually was thinking I changed that. Let me just change this right here. For this graph, it would be that I started with $100, and every year it was increasing by 3%. Now that would be correct. It's passing at 100, and each time if I were to multiply 100 times 1.03, I would be getting how much I actually have each year. Okay, let's go down. If its decay is just meaning that it's rapidly decreasing. It's not increasing, it's exponentially decreasing. So just like with the increasing, you have two different formulas. We're going to look at both. This looks exactly the same. There's nothing different except for that b is now not a whole number like 2 or 3 or more than 1. It's actually a fraction or a decimal. Any of those put in there and it's going to make sure that it's decreasing. So let's look at this one. Same thing. If I have 200, the 200 is going to be going for the y-intercept for the initial amount. But then if I'm spending my money, that's decreasing, and I'm getting rid of half of it at a time. So if you can imagine, you have $200, you get rid of half of it, now you have 100. You get rid of half of that, now you have 50. You get rid of that, now you have 25. You get rid of that, now you have 12.5. Okay, so each time it's getting less and less and less. What that would look like set up is that would be the 200 here, and then you would put the half in there. Anytime it's a fraction or a decimal, it's going to be decreasing. Big thing to remember. And then the same thing, the x is the time. So how many days, or how many, in this case, how many weeks did I actually spend my money that way? If it was only for 3 weeks, then I can figure that out. I plug in a 3 and it'll tell me exactly how much money I now have left. For right here, this is an example, and this is a big one where a lot of you, if you're getting your driver's license soon, you might be looking in getting a vehicle or getting a hand-me-down vehicle, but depending on what your vehicle is, all vehicles depreciate. The second you buy it, the second you walk off the lot with it, it's depreciating. And this is a big way to use this formula is to figure out what it would be worth after so many years. So let's say I bought a used vehicle for $2,000, and every year it's depreciating by about 12%. So 12%, how do I write that as a decimal? I write it like that. And for me to put that in, I put my initial amount, my y-intercept, and that goes right in the front where the A is, where the A would be. And then instead of it being 1 plus, because I'm going less than I'm not going more than 2,000, I'm going less than 2,000, it's going to be subtracting the 12%. If I figure this out, it's going to be 0.88, and I can write it either way. Both ways like this, you can write it, and that basically tells you what you'll have after so many years. This is what the graphs would look like. For this one, I have $200. You can see that it crosses at 200 because that's the initial amount, the y-intercept. And then after 1 week, that would be down to $100. After 2 weeks, it's going to be down to $50. Then it's going to be down to $25, and so on. On this one, the starting amount is at 2,000, and then it's decreasing, but it's decreasing at a slower amount. So if I actually wanted to plug it in, I have my calculator right here. I'm going to take 2,000 times 1 minus 0.12, and let's say for 5 years, then, oops, let's see. After 5 years, it's going to be, it says right here, if you can't see that, it's about $105. So you can see right here, after 5 years, that would be 5, 10, 15, 20, it'd be about, oh, I did 200, not 2,000. 2,000, let me try this again. 1 minus 0.12 to the 5th year would be, there we go. It would be 1,055. And if you look right here, it's right over 1,000. So hopefully that gives you a tad bit of an idea. If you're looking at tables, anytime you're looking at tables, the biggest difference between, and this is kind of what we were going over last week, let's say I have -2, -1, 0, 1, and 2, -2, -1, 0, 1, and 2, and let's say right here, this is going 8, 3, -2, -7, then what you're looking for to figure out whether it's linear or exponential is you're looking for how is it changing. Right here, this is subtracting 5, subtracting 5, subtracting 5, and if it's subtracting, adding or subtracting the same amount, this would be linear. So this is linear. This one, let's say I had 3 and 1 and 1/3 and 1/9 and 1/27, then each time I'm multiplying by 1/3, so notice it's decreasing because it's a fraction or a decimal, then since I'm multiplying by 1/3, multiplying by 1/3, multiplying by 1/3, multiplying by 1/3, I'm multiplying, it's the same, this would be exponential, and you would see in your graph, you would see it curve. So straight, curved. Hopefully this helped. If you have any questions, feel free to message me, and I will get back to you as soon as I can. Thank you for watching this.